Hello, everyone. Thank you for joining us. Good morning, good afternoon, and good evening to some folks that are joining us from across the ponds. Thank you for taking this 30 minutes to attend this webinar. My name is Keenan Zabuni. I work for Densify, and in this webinar here, we decided to do things a bit differently. Along with me joining is my company that we do a fair bit of work with, AMD. We have on the call Lewis Carroll. Lewis, if you can just provide a brief introduction about yourself.
Yeah, hi, thanks, Keenan. Good afternoon, everyone. So I am the director for technical enablement for cloud end customers to help get folks on board with the AMD instances that all of the major cloud providers are offering in the market.
Perfect, thank you. So the agenda for this webinar is going to hand it over to Lewis to talk about the AMD offering EPYC chipsets on the infrastructure and how that benefits companies such as yourselves. We also talk about what Densify's role in helping you realize the value when it comes to cost savings and performance, and also let you know about an offer that we've recently launched a few months ago between AMD and Densify for a select few customers upon qualifications of how you can take advantage of the actual infrastructure that AMD has on the public cloud in regards to benefiting both from a performance perspective and enjoying some cost savings. So with that, I'll hand it over to Lewis.
All right, thanks a lot, Keenan. One quick other comment. We will have time for questions at the end. So feel free to hold your question and ask it live at the end, or you can also type your question into the chat window. So as Keenan mentioned, we're here to talk today about optimization, with the idea being that optimization can allow for more capacity within a given cloud budget, a reduction in your spend, safely increasing your over commit ratios, or some combination of all of the above. For the purposes of this discussion, we'll define optimal as the acceptable performance from an instance or a service at the lowest cost that meets that performance level without any compromise on SLAs like availability or stability. So what's key here, and the reason we wanted to do this with Densify, is Densify's got tools and resources that will minimize the effort and risk that you as the end customer would need to deploy to achieve this optimization through, and it's the minimization of that risk is done through some really advanced data-driven analytics that Densify will deploy to solve your particular challenge. To give you an example of what might be in this for you, on average, Densify customers have been able to reduce cloud spend by 42% in the first 6 months of using the Densify program and taking the actions recommended by the system. And then, as mentioned, at the end, we'll talk about how you can potentially qualify for an offer for AMD to help fund you with a test drive here. You can go ahead, Keenan. Next slide. Okay, excellent. So real quick on AMD, I'm not going to spend any time talking about the chip itself, since when you're consuming cloud instances, you don't really care about the underlying hardware. But what's interesting is, we've been out of this space for a while and have only recently got back in. If you look at the timeline, you can see that we've only been back in the cloud space as a provider, an infrastructure provider to the major guys for slightly over a year. Where we are today, we're supplying AMD x86 data center processors to all of the major cloud vendors. For today, I'm going to really focus on the big three, but we are supplying to all of the major cloud vendors. But as much as we're just getting started and it's exciting to be getting started, the really exciting times are ahead of us as our second generation product ramps into production with offerings from, again, all of the major vendors. Our 7nm second generation has set over 140 world records to date for performance and power efficiency. And hopefully you'll see, as consumers of the products these cloud partners make, you'll see that performance and efficiency can be passed along with you to you. Go ahead, Keenan. So I want to do a quick run through of where we live in the cloud. So if we start with AWS, we have offerings in EC2 around the general purpose M5, the burstable T3, and the memory optimized R5. Now, what you'll notice is everybody's familiar with the nomenclature like M5.2x large. If you put a little a after the 5, now you're talking the AMD powered instance. Otherwise, it's exactly the same amount of vCPUs, same memory, same Nitro hypervisor, same NIC, same functionality, same attachment to block storage, same availability of NVMe, same instruction set, same. I'll come back to that because it all touches on the compatibility. As mentioned, these are all first gen EPYC based instances. Amazon has announced and will very soon be going into production with the C5A, which is built on second gen EPYC, and this is going to be a game changer in terms of performance. We're cautiously optimistic that you can get the trifecta of better performance at lower cost and lower power. Now, you may not care about the lower power, but AWS certainly does. And then finally, if you think about all of the first gen instances, anywhere you might use an AMD instance, it's going to be 10% lower cost than the same size and shape Intel instance. If you happen to have an opportunity to do your development in Mumbai, AWS is offering a 45% lower cost on these instances in Mumbai. So development there, you can save a significant amount of money. And the Densify engine is aware of all of this, which is part of how it does its recommendations. Next slide, please. Switching over to Azure and the virtual machines, Azure has two offerings based on first gen EPYC. The LSV2, which is a local NVMe, very heavy, large amount of NVMe, up to 20 terabytes, and then the HPC offering on the far right, the HB, which is a killer app for doing high performance fluid dynamics, weather, and rendering, and a few other applications, specialty compute applications in the cloud. On the second generation EPYC offerings, the general purpose DAV4 and EAV4 fairly recently went into production. They're deploying capacity as we speak, but these things are available now for production workloads. If you haven't test driven these, I highly recommend it. The performance of these has been outstanding for every customer that's checked them out. And then again, back on HPC, the bottom right corner, the HBV2 is the most powerful cloud HPC VM that has ever been offered. And Azure's published some amazing world records in terms of the magnitude of cloud computing jobs that they've been able to run on this VM. So if you're doing HPC, I definitely recommend test driving HBV2. Next slide, please. Our newest partner is Google Cloud. The Compute Engine team has deployed second generation EPYC in the N2D virtual machine family. Here we have the same typical offerings that N2 comes with, the standard ratio, a high CPU ratio, and a high memory ratio. And of course, GCP gives you the ability to do custom machine types. What's really interesting, if you look at the underlying processor, we enable GCP to deliver machines as large as 224 vCPUs. So if you're getting a huge instance to do, container or Kubernetes node, this is a phenomenal way to get a massive amount of, or massive number of vCPUs in a single virtual machine instance. And these are lower cost by about 13%. N2D is 13% lower cost compared to N2. Next slide, please. Now, I touched on compatibility, just to highlight this. I love the fact that, both AMD and Intel virtual machines, the stuff everybody's been running to date, it's all running the AMD 64 instruction set. You can see this throughout Linux, Windows, everywhere else. It's more officially, correctly now called the x86 64 instruction set. But the point I want to make is these machines are compatible. You should expect little to no effort to bring up. If you have an M5 virtual machine, you should expect little to no effort to bring that same virtual machine image up on an M5A. As mentioned before, the hardware, the AMD hardware is using the same virtualization platform, same networking disk controllers, and AMD works extensively with the operating system, open source, and commercial software vendors to ensure that, that we have functional equivalence and a high degree of compatibility. And Keenan's going to dive into this a little bit more as well. Next slide, please. So I'll wrap up my introduction here with a quick when to choose. One of the most common questions we get asked is, what workloads are best? And the answer is that any workload's going to work fine. The question is, what is your sensitivity to performance? The first generation EPYC based instances, so the AWS M and R and T, for example, they're using a first generation product. From us, the clock speed is a little bit slower, but as I mentioned at the beginning, if your performance is still good enough, why not take advantage of the cost savings? So what you're really looking for is workloads that are possibly running in excess of some acceptable level of performance or have a low degree of CPU utilization, or for whatever other reason, the workload is less sensitive to clock speed. And again, the Densify engine takes a look for this and figures it out and uses that to drive the recommendations for instances that should move to AMD and instances that shouldn't. We're not going to waste your time telling you to move a very performance sensitive instance off of Intel to a first generation AMD instance. However, when you look at the second generation, so this is the C5, the new Azure instances, the new GCP offering, as I mentioned, we expect to deliver same or better performance across all workloads, and we have a team actively working right now to prove that out. Next slide, please. So another way of extending your savings is to think about if you have perhaps one or even two generations older of hardware. If we use AWS as an example, let's say you have a workload running on R4, you can extend the cost savings that an AMD-based solution provides by adding on top of it the generational savings that AWS provides. So when you go from M4 to M5A or R4 to R5A, you get quite a bit of cost savings. And we have a very good customer success story here. If anyone attended the AWS reInvent event, Amazon talked about this in particular, where with Expedia, we were able to achieve roughly a 45% cost savings via a combination of modernization from R4 to R5A and migration of some workloads from R5 to R5A. We've also got several other customer success stories, some we can name, some we can't. The workloads here range from in-house developed software to some Java middleware stuff to microservices on EKS. But we're seeing customers take advantage of the instances. They're achieving the cost savings. They're doing so with minimal effort, and Densify is a big part of this. And at this point, I'd like to hand it over to Keenan to tell you about his offering.
Great, thank you, Louis. And what transitions here is we've actually been working with a number of these companies and speaking to the value of the insights that Densify's engine bring to the table. Some of these companies, specifically an insurance company, were able actually to transition 750 instances within a matter of 10 minutes through leveraging automations. And these are basically selective candidates that will work and perform better on an AMD catalog. So this speaks to the value of the insights that we bring in, hence that part of the partnership and the offer that we're about to entertain. For those of you that are not familiar with Densify, just a very high level summary, it's an optimization engine that will provide recommendations based on the precise alignment of your applications with the cloud catalog to ensure the optimal infrastructure environment. What we refer to optimal is achieving great performance at the lowest cost possible. Our offering spans across multiple of different hybrid environments, starting from the VMware infrastructure, the 4 big players on the public cloud, Microsoft, AWS, Google, IBM Cloud, and also containerized environment as well. How things works and how we actually gather data in regards to providing you these recommendations and right-sizing opportunities is through our patented technology. Our engine is called Chloe, Cloud Learning Optimization Engine. Through dedicated APIs, we actually connect to the infrastructure to track and gather a number of KPIs, anything from memory utilization, CPU, disk I/O, network I/O, storage, and the likes. We also have the actual infrastructure that the hardware, the hardware itself that the application is sitting on, whether it's the public cloud raw catalogs, Google, Microsoft, IBM, AWS, or the actual VMware environment. And we have specific performance benchmarks that we've actually obtained from, for example, Specta.org and other public cloud providers to enable us to create those benchmarking and thresholds that we measure against. Taking into account business and functional tags and policies, this whole process is governed by policies. You set up the type of policies that you want the engine to adhere to when we're coming up with recommendations. The end results will be 4 key criteria. Cloud resource optimizations recommendations to improve performance, stability, and reduce cost. Container and virtual environment, playing a very complex game of Tetris on your VMware or containerized infrastructure to provide the utmost efficiency level for those applications. Migration optimizations, having Densify run multiple of what-if scenarios of migrating infrastructure from one cloud to another, or from an on-prem data center, or consolidations of a data center, or a comparison between a number of chipsets available in the public cloud. And last but not least, purchase optimization, providing you the insight value of what the overall opportunity is for your infrastructure to log in on the right infrastructure to increase the performance, and how would you actually go about optimizing that from a financial perspective. All these answers can be delivered into multiple of different ways. Aside from our dedicated UI that you can access to, a lot of folks choose to have them in a dashboards, emailed directly to them, subscribing to the specific applications that they care about, and then when Densify monitors any recommendations on that applications, they can easily send the report or dashboard to that specific application owner. Complex infrastructures, we can easily connect through ticketing systems to launch a ticket and obtain digital approvals, or we can easily communicate with any other type of team communication tools, such as Slack or Microsoft Teams, to deliver those recommendations and have them action right within those platforms itself. We're not going to talk about automation stories here, but we can connect through a multiple of different orchestration engines. We work with CloudFormations, Terraform, Ansible, and then VMware Suite, just to name a few. Now, the question that we actually try to address is a common question that's pretty much addressed in every single complex infrastructure. Are you selecting the right capacity of your workloads? And if the answer is yes by some of you folks, the second follow-up question will be how? Where are you basing those capacity decisions based on what type of applications? Some say, oh, we've used M4 before and it worked fine, we're gonna go with the M4, or it didn't work fine, we tried the i3 and then we decided to go with the i3. This is the questions that Densify provide from a basic scientific perspective in regards to analyzing that infrastructure. The second main one is if you're optimizing the purchase strategy. So high level, addressing the first one, when we connect to the infrastructure, we tailor to both a multiple of line of business. First and foremost is the engineering, operations, and app owner team, working with them about performance and eliminating risk. And then the IT finance, working from a cost perspective and basically working with the budgeting and alignments to keep that cloud cost in line with the forecasted budget that every company has set forth. By doing that, from a type of analysis that our engine does, there's multiple of different ways that improve both performance and cost. Upsizing recommendations, we highlight any applications that are starving for resources, and we provide upsize recommendations to ensure that this risk will be fully eliminated. Modernizing instances, our bread and butter is a cross-family optimization, which we take a look at a workload that's sitting on an M category, which is a general purpose in AWS world, and then we mimic that workload and see what it does on a compute optimized instance or a memory optimized instance. Based on the actual history that we have gathered on the applications, we come up with the recommendations that this specific workload that are currently sitting on an M4 should be on an R5A, for example, because of the following reasons. And we provide the reasoning both from a financial implication and performance implication as well. ASGs, we have a full offering for auto-scaling groups, anything from determining the node sizes, the downsizing, setting up your minimum and maximum, which all these leads to tremendous cost takeout as well from any specific infrastructure. Now, in regards to long-term management, every type of answers that we actually put forth has a fully vetted evidence and a proof to enlist the trust of the actual application owner. A very basic example here is going from an M4 extra large to an R5A large. We're actually showing what that workload has been doing in the actual public cloud based on CPU utilizations at the bottom of the screen, and what the actual workload will be doing if you act on those recommendations. There's a number of other KPIs here that we actually track from it before, and the predictive what will look like after, to fully enlist the confidence of the application owner, saying that yes, if I act on this recommendation, I know that the performance will be increasing by this much. And from an IT finance perspective, If this recommendation gets implemented, then the actual cost saving will be this much. This is fully available in what we call applicability analysis report. Every recommendations that we put forth, there's a fully vetted report showing you the before and after picture in order from a confidence level perspective, ensuring that all parties that are reviewing this are fully confident of the actual recommendations. There's a cost implication, there's a risk factor behavior associated with that, along with performance improvement. From a purchasing strategy, first and foremost, we're not a bill monitoring tool. Bill is secondary to us. We analyze the actual workloads to come up with these recommendations. From a billing criteria, we provide the full visibility, whether it's the ability of tagging the actual accounts, providing the actual detail when it comes to optimization strategy. Having a fully vetted optimization strategy alone can achieve upwards of 75% savings over the spot use, on demand, and your committed use. I know cloud providers provide a number of tools in regard to that, but not to the great details that we're providing. As you can see on the screen here, this is an example of a step-by-step procedure to actually get recommended exchange done, including what the true-up cost is and the potential savings on a monthly basis. Financial visibilities when it comes to anomaly detections, pinpointing your outliers, or trying to track those recommendations that you're migrating between Intel and AMD, for example. How is that reflecting on the bill? Easily set up dashboards and reporting criteria to figure out which business unit is acting on those recommendations and what the actual cost is associated with those recommendations, along with the financial implications. Last but not least, as part of this offer, there's a page, if you can go to, it's available on the next page. This is what you're actually going to get. You're going to get within 48 hours of connecting to that offer, a customized dashboard saying what the potential capabilities and what the potential appetite from a cost perspective is that you can actually benefit and enjoy. Logging into the infrastructure, doing the Densify analysis, you'll get a sample report here showing you all the candidates that qualifies for an AMD chipset that's currently available right now. In this case here, there's a number of examples. For example, there's 12 candidates at the bottom of the screen here that's suitable for an R5A. You see the existing current cost along with the actual savings, projected savings if you act on those. Again, 95% of the Densify recommendations can be fully automatable. In this case here, we're literally telling you what the level of effort is that you can take advantage of. None, very low, it can be easily automatable, working with the maintenance window to implement those changes. Moderate might require some architectural changes. We'll vet that out when we have some qualifications and understanding what the application does. Last but not least, the actual estimated cost of impact when you're modernizing. And then again, our bread and butter, downsizing optimal family. And this is where the performance improvements takes place, because we're right-sizing the infrastructure and aligning it to the proper gear to increase the performance. By doing that, there's a far more greater cost takeout beyond the list price of any public cloud providers, which what Lewis alluded to, anywhere between 40–45% on your monthly spend. For more information, there's a dedicated page on this, www.amd.com/densify. There's a slew of information that you can go through. There's a form that you can fill out to take advantage of this. We can set up a call and determine the qualification status. The specific offer is being fully funded by AMD to help you better realize the value of the AMD chipsets. For those with smaller infrastructure, or you think that you're not going to be qualifying, we can still take advantage of this through our 14-day trial. Rather than having this engagement for 3 months, there's a 14-day trial. They can actually realize the same amount of value similar to the offer. Now, I noticed there's a couple of questions on the chat here. I think we have about 2 minutes to go through as many questions as I can, and I promise if I miss your questions, you'll get a response back along with the recording of this. One of the questions: how long you study the current environment for baseline performance prior to recommendations? Good questions here. As soon as we connect to an infrastructure, we have historical data upwards of 120 days. So it's far more beyond just a one business cycle. We capture all the peaks and valleys, and we have a thorough understanding of what that application has been doing in the past. And then that way we can come up with recommendations within 24 to 48 hours. Minimum historical data that we gather is 30 days. For longer engagement, we let it sit for a while, and then obviously to ensure that we have a thorough understanding of these applications. How is Densify licensed? Off topic to this webinar, but a simple answer is we're not a cloud cost at the end of the month. We don't charge you based on the amount that you spend on the cloud, because we think this is a moral hazard. We actually charge you a dedicated price per instance. So let's say, for example, you have 100 EC2 instances. There's a cost of, let's say, $6 a month per instance. There's dedicated pricing that's available in our website for more details. But the simple answer is we charge a set price per instance and not based on cloud spend. Question to Lewis: are there AMD sizes in all Azure regions?
Not all regions yet. They're in the middle of a rapid deployment of the new DA and EA. My recommendation is if you have a particular availability zone where you are interested, definitely reach out to your Azure team. You can also reach out to me, and we have connections into the capacity planning team, and we can tell you when it will be there and if it's not there yet.
Perfect, thank you, Lewis. Last question that we take up, just to be respectful of everyone's time, do we get access to all of the Densify features as part of this offer? The answer is yes, because all our features, basically, we're an agnostic engine. We're just showing the value of a specific chipset. So if the performance improvement and cost reduction is a key use case for you, the answer is yes. Other features is yes. From an ASG perspective, if there's recommendations, opportunities to improve performance, reduce costs, we're going to provide that to you as well. It's all available in the UI. There's no way for me or anybody within the company to lock down any functionalities. So you'll have actually the full benefit of the Densify engine when it comes to analytics, dashboards reporting, and recommendations to optimize the infrastructure that you currently have running on the cloud. With that, I want to thank everyone for joining. We'll share a copy of this recording. And again, if there's any specific information, please direct your browser to www.amd.com/Densify. And we're looking forward to talking to you on the next upcoming webinars. Thank you, everyone.